Good day, everyone. We have to look at how to calculate centroid again in mathematics in 6. So in this question, we are told to calculate the point of intersection of two graphs. That's graph number 1, y equal to negative 2x plus 7. Graph number 2 is x equal to 3 over y. Then after that, we'll sketch the two graphs and show the split that one will use to calculate the area bounded by the two graphs. So our story is all about two graphs. So let's go to the A part. So in the A part, graph number 1 is y equal to negative 2x plus 7. Graph number 2 is x equal to 3 on y. So to calculate point of intersection, all we need is substitute one graph into the other one. So we'll try to do that. So if I substitute, which one can I substitute into which one? So let me say I substitute 2 into 1. You can substitute any one into the other one. So what that means is that where there is x, I'll put 3 over y. So I'll get y is equal to negative 2 into 3 on y plus 7. So that becomes my new equation. So now that there is a fraction, the simple way to deal with the fraction is to make sure that the item at the denominator, you use it to multiply every term. Before we do that, let's try to simplify that item. This one will be negative 6 over y plus 7. So if I now multiply every term, every single term by y, then the fraction goes away, but the equation is not affected. So I'll multiply the left side by y, it gives me y squared is equal to, if I multiply this by y, it becomes negative 6 plus 7y. So we now see that the presence of the square is showing us that we've got a quadratic. So to solve a quadratic, everything must be sent on one side with 0 on the other side. So I get y squared, that will go as negative 7y plus 6 is equal to 0. So that's a quadratic. Once we solve it, we must get two answers for y. So you can choose to put it through the quadratic formula, or better still to use factorization. So when I'm looking at it, my factorization tells me I'll get y minus 1 into y minus 6 equal to 0, which tells me that y is equal to 1 or y is equal to 6. If you are not so sure about that, about factorization, you are very free to use the quadratic formula to solve. So from what I'm saying, if I expand this, I get y squared minus 6y minus y, which creates that here. So I think my points are correct. So if you're not so sure, please feel free to just substitute that into the quadratic formula to get to your answers. So to complete our point, we need to solve for the corresponding x values. So if I take y and put it into any of the equations, maybe the second one, if I put y there, I'll get my x as 3, because if y is 1, you get 3 over 1, which is 3, or the other y, if it is 6, if I put 6 there, 3 over 6 takes me to 1 over 2. So therefore, my point of intersection, 3 is to 1, and a half is to 6. So those are my points of intersection, and coincidentally all those points are positive, telling me that I must just focus in the first quadrant. So I have to focus on the first quadrant to sketch my graph, since my points of intersection are all in the first quadrant. So since we are only interested in the sketch, I need to look at the first quadrant. I need the biggest point on the x-axis is a 3. So I can say this is my 3, maybe this is my 2, this is my 1, and half will be somewhere there. So that is my half, 1, 2. Then if I go to the y-axis, I need a 6. So this is my 6. Maybe my 1 can be here. I'm only interested in the sketch. It must not be plotted to scale. So I need the point 3, 1. 3, 1 is somewhere there. And the point a half, 6. A half and 6, they are somewhere there. those are my points of intersection. So looking at the first graph, it's a straight line. To sketch a straight line, all you need are 2 points, and we've got 2 points already. So I just use my straight line, my ruler to link it so that it becomes straight. Then I get my straight line there. So I'm done with the straight line. Then the next graph is a hyperbola. So the standard equation of a hyperbola is supposed to be x, y equal to k. So if you cross multiply there, you see it's xy equal to 3. And the graphs will always fall in the first and the third quadrant if k is positive, like in our case is 3, or they will fall in the second and the fourth quadrant if k is negative. So looking at our problem here, you see that this is the same thing as xy equal to 3. So our k is positive. So expect our graph in the first and third quadrant. But since the points of intersection are all falling in the first quadrant, it means we're not interested in the third quadrant. So we just go to the first quadrant and we put our shape like that. So that is our graph. So the portion between the two graphs is therefore this portion. So that is the portion between the two graphs that I've shaded. So if you look at the shaded portion, it's quite a flexible portion because it can take any strip you want. If you want a vertical strip, you can fit there. I'm doing this to show to you that a strip is supposed to touch only two graphs all the time. So if you choose a vertical strip, you don't have a problem. If you choose a horizontal strip, you don't have a problem. So with this kind of problems, you can decide which kind of strip you want to put in your diagram. And then if you stick to the principles of that strip, then it will take you through. So I would like to start this problem with a vertical strip. Then later we can return to the problem and repeat it with a horizontal strip. So if I go for a vertical strip, that is my strip. I must always extend my strip out of the shaded portion. This is very, very important. If it touches the x-axis as you see, it immediately gives you information that if you are calculating the area in the P part, go to page 4 of your formula sheet as an NSET student. Look for that formula that ends with dx. The last formulas on page 4 of your formula sheet are the formulas for areas. So your formula will be something of this nature, y1 minus y2 dx. So that is your formula. That's the information the strip gives you. And this also reminds you that on your graph, you expect to see y1 and y2. So y1, because we are dealing with a vertical strip, y1 will be the graph above the strip, y2 below the strip. So that's our vertical strip. So y1 is this graph passing above the strip, which is the straight line, -2x plus 7. Then y2 is the graph passing below the strip, which is the exponential, the hyperbola. So from there, if you make y the subject, x and y will just interchange positions. So you get y2 being equal to 3 on x. So that is what we have about our graph. So with our graph, we are done. It's now time to calculate the area in the B part. So we just need to start doing our substitution. So in my substitution, I need y1. I can see my y1 on the graph, which is -2x plus 7 minus y2. I can also see on my graph, if you did your job like mine, these things will be easy. You see them on the graph, dx. Then we are a and b, because we are formula ended with dx. You must read a and b on the x-axis, where you started shading to where you stopped. You see, along the x-axis, we started shading at a half, we stopped at 3. So this becomes a half to 3. So we can now integrate. If we integrate x, it gives us x squared over 2. That 2 will take care of that. So we'll be left with negative x squared. We integrate that, we get 7x. Then minus, we integrate 3 over x, it gives you 3 in x, from a half to 3. So that is our integration. Then what's next? We need now to substitute our limit. So with our limit, we substitute the upper limit first. It will be 3 squared plus 7 into 3 minus 3 in 3. That's my upper limit. The lower limit, it's negative into 11 into, sorry, a half square plus 7 into a half minus 3, the ln of a half. So that's basically what we do. Then the rest will come from the calculator. So I will try to go through my calculator. The first term here will give me a negative 9 plus 21. So that's 21 minus 9. Then minus 3. Then the ln of 3. So that is it. Then the next side. So for the first bracket, let's sort this one out first so that we don't get confused. So the first bracket, I'm seeing 8,704 minus, and then sort out the second one. So I'm getting 7 over 2 minus 1 over 4, 7 on 2 minus 1 on 4. If you do that, then minus 3, the ln of a half is 0.5. So the second bracket gives us 5,329. So if I do this simplification, then I will see my area. So minus 8,704. So my area is 3,375 units squared. So that's how simple it is to get our area in this situation. So guys, we are done with A and B. We can now switch over to C, which is where the main story steps in. We need to calculate the centroid, and this time the make life very easy for you. They simply say calculate the x-ordinate of the centroid. If they wanted to make life complicated, they will say calculate the distance of the centroid from the y-axis. So distance of the centroid from y-axis is the same thing as x-ordinate of the centroid. So now that I'm sure of what I'm calculating, the x-ordinate of the centroid, as an N6 student, you need to go to page 5 of your formula sheet. There is a subtopic there called centroid. So there you look for the formula for x bar. X bar is defined as area moment about y divided by the area, where in this case the area is what we've just done, to the 3,375. So the area moment about y is defined on the N6 formula sheet as the integral from a to b RdA. So our area moment about y is defined is on the same page 5 of your formula sheet as the integral of RdA is just above the formula for the centroid. So I have to develop this using my diagram. So dA is the first thing I do. It's just the formula for the area. I'll just finish using to calculate my area. So I'll copy that one down, the integral from a to b. I will leave space for r. Then I'll put my y1 minus y2 dx. That's my formula for dA. Then my r, to get it right, this y-axis is very, very important. To get this one right, I must go back to my diagram. I start from the center of my strip and move to the y-axis and see my direction of movement. So I'm going back to my diagram. I want to start from the center of my strip. Then I move in a straight line till I hit the y-axis. So I'm moving in a straight line to the y-axis. So when I look at the top, the dotted line I've put there, you see it's a horizontal movement. Each time you get a horizontal movement, you describe your R using X. So in this case, our R is a simple X because of the horizontal movement. So take an average if the strip was also in the same direction, but here it's very simple. So here our R is a simple X. So that is our R. So we can now substitute substitute the upper and lower limit by the same ones we use for area. So you take 1 over 2 to 3 x into y1 minus y2. Don't forget we did y1 minus y2 there already, which is negative 2x plus 7 minus 3 on x dx. Then if I open my bracket, I will get the integral from a half to 3 of negative 2x squared plus 7x minus 3 this time, because this x will take care of the x at the denominator. So we get our dx there. Then we integrate. So the first term will be giving us negative 2 on 3 x cubed, followed by 7 over 2 x squared, then minus 3x from a half to 3. Then we substitute our limit, negative 2 over 3 into 3 cubed plus 7 over 2 into 3 squared minus 3 into 3. Then lower limit, we get negative 2 over 3 into a half cubed plus 7 over 2 into a half squared minus 3 into a half. So this is what we are going to do to get to our area moment about y. So this is where the calculator steps in to help us. So I'll try to go through that. 3 cubed, you are 27. 27 over 3 is 9. 9 times minus 2 is negative 18. So I've got negative 18 there. 3 squared is 9. 9 times 7 is 63. So I'll take 63 over 2 plus 63 over 2. Then minus 9. 3 times 3 is 9. So the first bracket is giving me a 9 over 2 or 4 over 5. So in my first square bracket, I get a 9 over 2 minus. I'll go to the next. A half cube is 1 over 8. So I'm taking negative 2 on 3. Negative 2 on 3 multiplied by 1 on 8. So that is what I get. Then plus, and this one is a half square is 1 over 4 times 7 over 2. That gives me 7 over 8 plus 7 on 8. 1 on 4 times 7 over 2 is 7 on 8. Then minus 3 over 2 in the last one. So that gives me negative 17 over 4. So this negative is the one out of the bracket, and the square bracket there gives me a negative 17 on 24. So if I now do that simplification, I will take in 9 on 2 plus 17 on 24. So that takes me to 1, 2, 5 on 24. So this is my area moment about the y-axis. So therefore, if I need x bar, I'll simply take area moment about the y-axis, which is 1, 2, 5 over 24. I divide this by 3,375. So if I do that division, 3,375 gives me 1,543 units as my x bar. So I will now need to return to my diagram that I drew to figure out whether this answer is correct. Because when you calculate the centroid, you can see it on your diagram whether it's correct, since we're looking for the x coordinate. We are going to check our diagram. On our diagram, we shaded the portion on the x-axis between a half and 3. So the centroid must be a number between a half and 3. So guys, you can see that it's very obvious that our answer is correct. So that is it. Thank you very much.